Hello, everyone. Welcome to another episode of Functional Futures. And on today's episode, we have Oscar Spencer, a WASM guru, the director of engineering at Suborbital Systems, a company making commercial framework that allows to deploy and run code within any backend system, from software as a service application to your own classical on-premise infrastructure. And they achieve the safety of this whole ordeal by using server-side WASM, which provides good isolation while still allowing developers to integrate with the environment. He is a co-author of a WASM first, or should I say WASM only, functional programming language called Grain. Hello, Oscar. Was my introduction fair?
Hello, hello. Yeah, I think your introduction was pretty fair. That's pretty much me in a nutshell. Just sort of sitting around doing WebAssembly all day, all day, every day.
Right, and you've been doing it for a while, right? You started Grain a long time ago, and back then,
Yes.
it was 2017, right?
Yep.
Uh,
2017.
so were you a WASM guru already then, and figured, oh, I should make a language, or how did that go?
Yeah. No, I wasn't. I wasn't really a WASM guru. I mean, I don't think too many people were back then, other than the folks at Mozilla. I think at that time it was right when WebAssembly had just got turned on by default in all of the major browsers, and I was a huge front end person back then, and so I got really excited by the idea of, hey, wait, we can run languages that aren't JavaScript in the browser. Absolutely, I want to give this a shot. And so at the time, I'd actually just completed a compilers course, and I thought it'd be really interesting if I, put something together with a buddy of mine that targeted WebAssembly. And then, we did that. I'll never forget, the shock on our faces when we managed to bind a DOM event from inside of WebAssembly. That was absolutely amazing. I think we both jumped out of our chairs with excitement of like, hey, we clicked the button and WebAssembly happened. So that was really exciting. And yeah, it's crazy to think that that was back in 2017. So in a way, yeah, I feel like I grew up with WebAssembly. So I've just been here for the ride all along, learning as I go, and I mean, it's been great.
A lot of people these days are basically more or less in the position like you were. What is it, 5 years ago? While working on Grain, how did you learn the concepts of this? Virtual machine and how it's executed. Did you just read the specification like 20 times and it clicked, or like how was the process of learning for you?
So funny enough, we had a lot of help. So the grain compiler initially was targeted x86. Kind of. I don't want to call it boring, but so these days it was maybe a little bit boring in that sense. And so we had the official WebAssembly spec, online that everyone could read. However, there was an actual reference implementation of WebAssembly written in OCaml. So that felt like a little bit of a cheat code for us because it didn't take too much for us to figure it out. All we did was we just downloaded this WASM library from OPAM, and then we just changed that as our target. We were like, hey, we're going to swap out most of these instructions with WebAssembly ones. Doing stuff like register allocation was super easy because, in WebAssembly, we have unlimited registers. So it's actually not too bad to get started, especially, if you're an OCaml nerd like we were and still are, then, we had a pretty easy time of it. So yeah, definitely a little bit of a cheat code in the beginning. But after that, it's mostly just, reading specs, chatting with folks. There's so many lovely people who are happy to help you understand sort of anything going on in the community. You just gotta, reach out and say hi, and folks are more than happy to help you out.
Right, and when I was growing up, figuring out difficult technologies, and I mean, I know that there's a very popular cliche in WASM community that, oh, WASM is very simple VM, it's very easy, but like the spec is what, like 200 pages, I think, like 160,
It's
something like
pretty
that.
long.
Yeah, and I
It's
mean,
pretty easy to navigate, but it's pretty long.
yeah. I mean, that's. I think that's kind of like for us Haskell developers, like, oh, what is there to not understand about a monad kind of thing, right? Like when
Exactly.
once you get there, it's kind of easy, but like it can be rather daunting. So yeah, when I was like growing up, for us it was all IRC. Like you could go to IRC to, well, back then Freenode, but now it's obviously Libera, and chat there. I see that your community is based in Discord.
Mhm.
When like, what is kind of the place to go for a beginner to ask questions about WASM and its peculiarities?
Yeah, absolutely. So there is an official WebAssembly Discord that folks can join, and sort of people chat about everything WebAssembly in there, from things that you might not even imagine people are doing with WebAssembly. Folks are chatting about it in there. But I think joining these circles, but also the specific circles for like the actual languages and frameworks you want to use. In those circles, you can get a lot more specific. Folks are going to have a little bit of better answers for, okay, how do I do this exact thing in Rust, or how do I do this exact thing in Grain? And folks are going to be able to get you really good answers there, because like you said, WebAssembly is still pretty new. It's not easy to figure out exactly, like, hey, maybe you've managed to produce a WebAssembly module. How do you actually go deploy that and run it in production, right? Are there tools out there that can make it easier for you? There are folks who are running WebAssembly in Kubernetes and getting really crazy with it. But the way that you're going to find out about these things right now is through that personal chat, chatting with folks, mostly on different Discords. We are going to get to the point where we've got all the tooling in place and it's super easy and everything's well documented, but we're still not quite there yet as a community, but we're rapidly getting there.
That's great, and of course we'll attach all the relevant links into the podcast notes. Um, well, okay. Before we go into the technical details, even though I'm already excited to go there, once I learned that you were using this OCaml library back in the day, can you tell us a little bit about your vision for Grain? As far as I understand the documentation, like if I had to do an elevator pitch for Grain, I would say that it aims to be the Golang of WASM. Is that a fair analogy? And what's your vision?
Yeah, sort of in a way. I think my vision for Grain long term is to be that easy entry point for people into WebAssembly, with the very sly plan in the background of letting functional programming take over the future. The whole point is to have this language that's extremely approachable. And I think this is a concept that I have really picked up looking at like the React framework, looking at ReasonML, languages like this, where you can take some pretty quote unquote advanced functional concepts, right? But if you present them in a way that folks say, hey, actually, yeah, this makes a lot of sense. I'm not getting bugs in my code, right? When you're able to tell those stories about how like messenger.com went from 10 bug reports a day to 10 bug reports a year after switching to ReasonML, when you're able to tell these stories, that gets people really excited. And so we're trying to do a lot of that with Grain and say, hey, we can give you all of this type safety. We can give you all these functional features where you're going to be able to write really good production code, but it's not scary. It's approachable. All right. Yeah, we're breaking a couple rules in Grain. Like we have, let mute. You have mutable bindings by default, and that's probably scares some people. But we want to have these places where folks can come in and really feel like they're at home, like they feel like they're writing a language that they're super comfortable in, and that they just really feel good about. And along the way, it's going to be teaching them functional concepts and teaching them, hey, actually, yeah, with all these functional features, just the power of pattern matching, which at this point I don't even really think is that functional of a feature anymore, but just exposing people to these things and getting them excited about it. So that's a lot of where we want to go with Grain, is just providing just a rock solid developer experience. Just having folks feel really good writing whatever programs they want, basically being that 90%. So 90% of the programs you want to write, you can write them in Grain, and the other 10% of WebAssembly you need to write, you can write it in Rust. That's sort of where we're aiming as far as how high of a level of a language we want to be.
Right. Uh, to clarify point here, so I've seen a lot of comparisons between Grain and Elm as well,
Mhm.
and so the my personal experience with Elm, and I don't think that Elm author will come to our podcast after I say this, is that it's roughly 80-20, but stuff that's 20 is like really borderline impossible. Like you have to go through such hoops to like get the 20% of use cases that 80% don't cover, that it almost makes me personally, and again this is just my opinion, question if I should even go for it in the first place. So how do you go about like kind of creating escape hatches for people who like know what they're doing and they really need this like escape hatch. Like, I don't know, like, you know what I mean.
Yeah, I know exactly what you mean. And that's something that we've been toying with. We want to make sure folks are able to do things in Grain that we don't necessarily endorse. And so we have a couple features to do this. So one of those, for example, is we have an attribute you can put on functions called unsafe. And it's an attribute that allows you to say, hey, I'm just going to drop down and write low-level WebAssembly right here, right now. Like, we're going for it. We're going to do it. And this is not something that I want 99% of users to do. However, we're going to make sure that it's possible. Well, for one, it made things a little bit easier for us. The entire runtime for Grain is written in Grain, and we're probably not going to be able to to do that without being able to just write some, bare WebAssembly stuff. But it's providing escape hatches like this. In the language where folks can do things, especially when it comes to, for example, binding to a WebAssembly host. Right now, doing that, it's some low-level code, right? And that's not something that I expect, every user to do. And, we're working on projects like WitBindGen that allow you to automatically generate, Grain code to bind to these interfaces, so you don't have to do that sort of stuff. But yeah, we want to make sure that we have these things in Grain so folks can go wherever they want. And I'll even add on to that. One of the big exciting things about WebAssembly is the WebAssembly component model, where we want to be able to mix languages. We want to be able to pull in components from all over the place. So sure, maybe you don't want to write that cryptography library in Grain, but that's okay. You can pull in Rust's amazing performance cryptography library and be really happy with it and integrate it into your Grain code. Are we there right this second? No, but we can actually get there. And I'm telling you, if someone came into the Grain Discord and said, "Hey, I'm trying to statically link to this Rust binary," I'd say, okay, let's make it happen, because that's something that we can actually, make happen if folks are asking for it now. But this is definitely where WebAssembly is going in the future. And we'll have these different ways for you to get that last 10% that you might not have wanted to write in Grain.
That's really cool and very very pleasant to hear. So, in terms of, I think I'll skip ahead a little bit. You mentioned several things. You mentioned bindings to
Mm-hmm.
host platforms. I'm sorry, I'm very very new to WASM. So as far as I understand, these are kind of capabilities of that are provided by like host. Like, for example, file system would be one such
Mm-hmm.
binding, right? Or
Yeah, absolutely.
like local storage in a browser, for example.
Yeah, exactly. So it's basically, so just to do a little bit of level setting, WebAssembly code runs in a sandbox. So it's completely sealed off walls with absolutely zero way to speak to the outside world at all. And this is how WebAssembly gets to be secure by default. So the way that we start adding on new capabilities, because maybe, hey, you do want to talk to a file, or you do want to talk to, the network or something, we add on these capabilities back via host functions. There is a set of host functions for common system calls. This is WASI, the WebAssembly system interface, which provides a standard way to interact with all of these different, system calls on a system. So we have that, but additionally, you can have your host provide whatever host functions you want to do all sorts of things. So, for example, there are a couple of game engines where they give you some host functions that say, "Hey, here is a controller input," or "Here is, a buffer that you can write to for like the graphics or whatnot." And so that's super cool. And there's going to be all sorts of different hosts providing all kinds of different, host functions, right? Even at suborbital, um, we want folks to be able to do things like talk to a database very easily. And of course, we could let you go and make a network connection and do all that fun stuff. Or we can just give you a function that says, "Hey, I want to query this thing," and go from there, right? So that's all, what host functions are about. And of course, yeah, well, folks need to be able to bind to those host functions, but they're very low level things. Like, we're talking, if you've ever written C bindings into a language, it's sort of exactly that. You're writing those sort of bindings to, what these host functions look like. And yeah, like I said before, we are, working a lot on automating a lot of this so folks don't have to do it themselves.
Right. And again, like a novice question. You mentioned linking, and I have a whole kind of block of questions later about linking, but I guess let's bump them to right here, right now. So my, again, absolute beginner understanding was that when you compile something using like to WASM, it generates this bytecode, and then it runs in any, well, runtime that can run WASM bytecode. So
Hmm.
when you say so, um, and my like assumption was that for every like complex multi-module or multi-library project, uh, this process would be like static linking. You would get just one large blob. But while reading about Grain, I learned that it first was dynamic linking, and only
Hmm.
then you implemented static linking. Can you tell me a little bit about why was dynamic at the default, and how is it even possible? Like what, how can I dynamically link, for example, something for the browser, and like how will browser runtime assemble, no pun intended, assemble the resulting, executable versus like x86, where, right? Yeah, please go ahead.
Yeah, absolutely. So the reason why we were dynamic in the beginning was, and this is silly young naive Oscar. I really thought that WebAssembly was going to be all in the browser. If you had told me, hey, in the year 2022, server-side WebAssembly will be like 80% of what people are doing, I would not have believed you at all. But that's where I thought we were back then. I really thought everything was going to be in the browser. One of the things that's really popular in the browser is code splitting. Where it's like, hey, I want to take different parts of my application and ship them individually to improve load times, things like that, just dynamically link these pieces of my application together. And so that's where we were coming from with Grain. We made it so the Grain compiler, for every Grain file you wrote, it would compile to its own WebAssembly file. And then in the browser, when you loaded your first WebAssembly module, it would see all the dependencies of that module and load those WebAssembly modules as well. In terms
I'm
of
sorry,
actually linking,
sorry to interrupt. And this is a property of WASM specification itself, right? Like it allows for dynamic linking itself.
it does, though back in 2017, we definitely were not following the spec yet.
Hmm.
Back then, we sort of rolled our own solution where it was literally we used the WebAssembly module. So there are these custom sections. There are sections in WebAssembly module for like your code, for your functions, data, things like that. We use the custom section to define, all of the dependencies of a single module. So at runtime in the browser, we could dynamically load all of the WebAssembly modules that you need. And that's how, things worked back then. And this was all fine and dandy, but we ran into a problem of, well, how do we actually run outside of the browser in all these WebAssembly runtimes that were cropping up? And that's where we introduced dynamic linking. So what, or sorry, static linking, I apologize. So what we could have done was we could have said, hey, let's just go ahead and just, when we compile a program, just concatenate all your code together and just put out one jumbo WASM file. That's a pretty easy solution. But we liked having all of these artifacts around with compiled code. It would be a quick way to have developer experience be a little bit better of not having to recompile every single library you depended on when it's time to build that module, right? So what we did was we said, hey, I said, how hard would it be to build a static linker for WebAssembly? And I said, probably not too bad. And then I set out on doing that. And somehow I managed to do it and it worked. And we could, stitch all these WASM modules together to build one static, module, which has kind of been great. It's been really convenient for us, ever since then. And of course, since then, the spec has evolved on both fronts. So we actually have WebAssembly interface types, which is a well-defined way of, hey, here's how you stitch modules together, either at runtime or at compile time. And there's even a tool called, I believe it's called WASM Link now, which essentially is a standalone WebAssembly linker for you to link, these sort of modules together if they conform to interface types. So we're definitely still working to get fully compliant with, the spec there. But yeah, it's really exciting that we have these pieces together. Now, a few of the WebAssembly runtimes even support dynamic linking, by themselves without you having to write any extra code. So really exciting times we're in. And that's how we're going to get to using all these modules from different languages and stitching them together. There's a bit more that needs to happen with like the WebAssembly GC proposal and things like that to truly reach the dream, but we're not too far away.
Right. Well, let's get back to like top level a little bit. So I briefly looked at the Grain repository, and I saw that the compiler is written in aforementioned ReasonML.
Mm-hmm.
Um, it's I don't uh, you know regularly see code written in ReasonML. and
Mhm.
especially not one originating from 2017. Can you please,
Mhm.
yeah, talk a little bit about the language of choice first, and second, how do you get ReasonML to actually emit WASM? Because as far as I understand, it's kind of like dual targeting uh, language, right? Like it targets JavaScript, and I think it targets like x86 or normal.
Mhm.
Yeah, please
Yeah,
tell a
just
little bit.
yeah.
Yeah.
Yeah, so funny enough, back in 2017, the Grand compiler was just written in pure OCaml. And so the reason for OCaml is, that ML part stands for meta language. It is the perfect language for writing a language. I will take that to my grave. No one can tell me otherwise. I like developing the compiler in OCaml has been an absolute dream. If you want to tell me that OCaml is bad for all these other use cases, whatever, but like for building a compiler, OCaml is fantastic. So I'm not exactly sure when it happened. I think it was maybe 2019 or 2020 was when we made the cut over to ReasonML. Um, and the hilarious reason for that is, yeah, there aren't a lot of OCaml developers out there. Like they definitely exist. We're here. We're a community, but there's not, that many of them. And at this point, ReasonML had gotten more popular, probably, quite a bit more popular than OCaml at this point. And it was a pretty easy switch. We could just run a tool to convert all the OCaml into ReasonML, and all of a sudden we have a full community of people who might otherwise be interested in coming and contributing to the compiler. Open source is hard and we need as much help as we can get. And that's sort of like the origins of why we are in ReasonML. It's just to have the still glorious OCaml programming to write our language. To your other point of how do we get ReasonML to emit WebAssembly? Yeah, it's not actually the ReasonML compiler. So the grain compiler just ends up being this regular just regular binary, right? But the actual WebAssembly emitting happens via a project called Binarian. So Binarian is a project that is essentially like it gives you an IR to target just with WebAssembly instructions, and then it can serialize and deserialize modules for you. It's very, very convenient. And of course, on top of that, has loads and loads of optimizations. So we could have useful LLVM for our backend. And, Binarian is the project that is behind LLVM as well, but we didn't need that. We really knew that, hey, we're targeting WebAssembly, let's just sort of skip all of the LLVM bits and let's just go straight to Binarian, because we still get all the same WebAssembly optimizations that you get if you were going through LLVM, not the LLVM IR ones that can be pretty powerful, but we can handle that. Like that's something that we can take care of ourselves. But yeah, we wrote some OCaml bindings to Binarian, and that's what we use to generate WebAssembly.
That's really cool to learn about Binarian, and also that you defer optimizations to it. But for me, again, I'm not a like expert in. I mean, I made toy languages, right? Or I made like domain
Mhm.
specific languages, but that's sort of like kind of, I would say, full stack language. I've never made. So when I think about it, right? You mentioned runtime, and we'll get to it eventually. Perhaps it's a way to get to start talking about runtime. But like, on one hand, it's really cool to defer optimizations to like an IR framework like this. But on the other hand, like, how do you make sure that this optimizations kind of make sense for your runtime? And like did you need to make any adjustments in the process of using Binarian?
Yeah, so just to clarify, so we do have a full suite of optimizations as a part of just the grading compiler that we do run. And so you can sort of think of these optimizations as enabling Binarian to do more optimizing.
Oh,
So it's mostly saying like, okay, like we might have a bit of code that at the WebAssembly level, Binarian wouldn't necessarily understand how to optimize, but something that we totally understand how to optimize, and we can take care of that. So we have a bunch of our own passes that we run, and then after that, we additionally can have those binary optimizations. Yeah. Um, yeah, it's a lot of that. It's sort of adapting our code to make sure we're putting out WebAssembly modules that are easily optimizable, things like that. And in fact, our brand new grain release, which by the way, this is sort of, I guess, first announcement out there. Last night we released grain v0.5, which is incredibly exciting, and we'll be announcing that right after this podcast. So super excited about that. But we did a lot of work to enable more and more binary optimization. So you'll actually see that the grain modules now are on average 30% smaller. In some cases, they're running quite a bit faster. We really put in a lot of work to this exact end to make those optimizations better, let people feel more comfortable going to production with grain.
Nice. That's cool, and also I'm glad that that's basically what I thought the answer will be.
Yeah.
So, so okay. So, from what I know about WASM so far, is that WASM itself does not define a runtime. It's
No.
up to the kind of users of WASM spec to figure out, okay, how do we actually want to run this bytecode. So, and this is where for me it gets kind of intellectually tricky to figure out what do you mean when you say runtime.
Yeah, it is a tricky one. When I say runtime in Grain, I'm specifically referring to, I guess, sort of two things. The first thing is memory allocation and garbage collection. So that's sort of like the first thing is like, hey, how do we actually manage all of this memory and everything we're doing, all these objects that we're allocating? That's the first big piece. And that's incredibly important. There is a whole WebAssembly proposal for garbage collection that's in the works, which we are incredibly excited for, and I think is going to be a major piece in getting modules across languages to link together. That's the number one concern you have right now is you can have two WebAssembly modules that do something, but to make them talk to each other, they're just going to be writing over each other's memory, and that's sort of the biggest concern right now. So that's like the first bit that's important. And then the second bit for the grain runtime is sort of all of the support infrastructure for things like the print function, for things like the toString function, stuff like that. So just sort of like the language support stuff that you expect to exist in the language. But that code has to actually exist somewhere. It's not just given to us for free.
So in terms of grain, I understand that you made runtime yourself, and can you talk a little bit about its properties? Like, I don't know how,
Yeah.
you know, like, is it strict? Is it lazy? Is it what's your garbage collection strategy, etc.
Yeah, absolutely. One thing about WebAssembly is some people feel that it's kind of annoying. Other people feel that it's fine. Is WebAssembly essentially, or at least the way you write WebAssembly is as though it's running on a stack machine. So you push values onto the stack, you pop values off of the stack, you have a good time. That's all fine and dandy, but one of the things that WebAssembly does not allow you to do is inspect your stack. So there isn't really a way to just see, hey, what values are on the stack? What values are live? So can I actually, walk my stack and do some garbage collection? That's not something you can do with WebAssembly today. So the way folks have gotten around this is, they've implemented their own stack and just have the actual WebAssembly code manipulate the stack that's in memory. That's one way to do it. For us, we chose, hey, let's actually we'll use the WebAssembly stack as intended. And so that means, that gets rid of a whole class of, garbage collection that we could potentially do. So instead we do reference counting garbage collection. So we just keep track of, hey, how many references do you have to this thing? And, if it goes dead, then, we reclaim that memory. And so that's really, all that happens there. It's fairly simple, but it's still a garbage collector, which means it is a pain to maintain. And so we're always, looking up to the WebAssembly spec gods and asking, please deliver us GC. Like we will be so grateful when we no longer have to maintain this. Nothing hurts my soul more than a GC bug, and just the hours and hours lost
Oh,
to
yeah.
debugging that has been terrible. But yeah, that's mostly what's going on in terms of the language properties. Yeah, we're fairly strict. We evaluate things. When you write it, it's evaluated there. You don't have to worry about like, oh, is this going to be lazy? Is this happening later? Which I think might come as a disappointment to some. Some people might want to see lazy evaluation everywhere, but yeah, no, we're pretty strict.
Right. Yeah, this actually brings me to the question of you throughout this interview you say a lot of phrases like as of today WASM has this property, um,
Mhm.
and um, like how do you cope with changes in the spec, because I assume that you want to be on the forefront at all times, right?
Yeah, absolutely. I think that's one of our biggest challenges right now. There are some runtimes that we support now when we want to support that are maybe a little bit behind the times and keeping their WebAssembly internal engine up to date to actually be able to run some of this stuff. Um, and that's a problem because we want to continue moving fast. We want to be using all the latest features and whatnot. So we have a handful of compiler flags to deal with this. Turning off specific classes of instructions. So for example, we have a flag that's no bulk memory. It's like, hey, just don't use bulk memory instructions, and you'll get some polyfills of these things, which is kind of a little sad. We do want to be on the forefront of things. So I will say a lot of folks are pretty good at updating their runtimes. We probably will end up having just more flags to turn features on and off, but come the end of the year, I think we might get a little more strict. It might start just dropping old WebAssembly features because, yeah, WebAssembly is rapidly evolving. We're seeing proposals land, things are happening. So I think like a really big one is like tail calls, for example. We waited a long time for WebAssembly to have support for tail calls, and now we do. And if anyone ever opens an issue on Grain saying, "Hey, I wrote a tail recursive function, but it blew the stack," I I will not be happy, to say the least, because this is a feature that like exists in WebAssembly, but not all runtimes support it, and so by default we don't have that flag turned on, right? And you do have to know to turn on that flag, in certain runtimes. So yeah, I think it is kind of just going to come to the point where we're just not going to support old features. We're going to be expecting folks, proposals that were marked finished a year ago. I think we can safely say, hey, yeah, you need to go upgrade your engines if you want to continue using the language. But honestly, I think some of the old versions of Grain are pretty good too, and so like they might be stuck on one version for a little while, but I think that's okay.
And in terms of you personally, like, or your team rather, uh, so you mentioned that there are features that are getting implemented for WASM, but
Mm-hmm.
are there some like breaking changes? Do you need to do a lot of refactoring to accommodate those new features, or breaking changes?
I have to say the WebAssembly team did an amazing job at making WebAssembly be in a position where it didn't have to have a ton of breaking changes. So the binary format, the major version has not changed since launch. We're still on version 1 of WebAssembly. So like there's no sort of random bytes that are going to just straight up crash a runtime other than new instructions that have been introduced. And so some runtimes, when they're trying to load a module, might just say, oh, I don't recognize that opcode and I'm gonna die. And that's okay, like it happens, but in terms of like all the tooling to prepare the WebAssembly and whatnot, all that stuff continues to work. So we haven't had too much trouble in terms of breaking changes, so that's like, ugh, like here they go again. Like, breaking stuff. It's actually been quite pleasant. And I think there's a proposal right now for WebAssembly feature detection, if I'm not mistaken, to just make sure, hey, I know that this runtime is going to support these things, and you can compile different versions of your modules depending on what features are available. And that'll be pretty nice when we can do stuff like that. As long as we're able to support a couple flags that turn features on and off, then we're okay. Yeah.
That's actually very impressive because I mean, again, I don't know for how long it was in the works, but to me, making like hitting the nail on the head from the first attempt when it comes to like such a diverse VM that is supposed to like be the new run write once run everywhere. It's a
Hmm.
pretty impressive job. Um, so, but okay, but in terms of your early work, if we go a little bit back in the history,
Hmm.
how would you, well, like, did you hit the nail on the head from the first attempt? And if
Oh,
not, then
absolutely not.
yeah, I mean, it's still
Yeah.
0 point something, right? So it's
Yeah.
absolutely fair. So what was your experience with like refactoring, actually the compiler code, or your bits of runtime that you write, etc. Like, yeah,
Yeah, so that experience there was sort of the journey of going from a toy language to like a real, actual, serious language. Because yeah, in the beginning, the code base was kind of just the result of a school project, and I don't know about you, but I'm not really trying to ship code from a school project to production, right? So it was a lot of sort of refactoring, rebuilding a lot of pieces from the ground up to make them, production class. Ever since, then, like, obviously I've grown a ton as an engineer. Other folks, on the team have grown a ton as engineer, like just engineers in general, but also compiler engineers, and just understanding more concepts and, things that we should be doing right, as we're developing. So I think a lot of it was, refactoring code that way, refactoring a lot of ideas we had in the language of just how we want to reason about things, really hitting, okay, where exactly do we want the language to go? Because in the beginning, we didn't necessarily know. We were just kind of having fun, and, we saw an opportunity that was, hey, if we put in a little bit of, effort, a little bit of elbow grease, we can actually build something that people are going to love to use, and people will actually want to use, because yeah, fundamentally, a lot of the languages we have for WebAssembly right now are just super low level. And that's fine, for some folks writing WebAssembly, they can deal with that. But the vast majority of people probably want to write a bunch of high level code. And so it's a lot of how can we mold Grain to more fit that bill? How can we get Grain into a place where it's super approachable for people to like write code and run it, and it runs reasonably fast. Like, isn't going to be as fast as this like very serious Rust module? Like, maybe no, right? But like, most people probably don't need that, given how fast WebAssembly is. So it's a lot of just reworking a lot of the ideas of the language, and of course there's a lot of code with that too. But yeah, the road to 1.0 is paved with many, many features and things we want to get done. Like a huge one, that especially folks have been asking for is like macros. All right, like we want to have macros in the language. That's a big, hairy feature that hopefully we get a chance to start working on soon. But it's going to be things like this, like the sort of, I guess, big boy. I graduated from compiler school. I can implement these sort of features, sort of things.
Yeah, I'm not sure. I'm not sure what's your plan for macros, but when I'm thinking about implementing macros, I'm trying to stick as close to Elixir as possible,
Okay.
because their macro system is just amazing. You just keep writing code, right? Like you just write like for outside a module, and then you put def module in the for loop, and then it just generates a bunch of modules. And yeah, the way they do it is very nice, and they have actually a lot of industrial grade applications. For example, my favorite example is Unicode module. So basically, they take Unicode standard, and then they load it at compile time, and they generate code from the standard. So they, all you need to do when Unicode releases more emojis is download new standard, compile Elixir, and you don't need to like patch anything basically.
Oh, that's super cool. I
Yeah,
love that.
yeah, yeah.
Wow.
So yeah, check this out for sure. But like the secret to me is that Elixir is actually Lisp in disguise,
Yeah.
so it makes it a lot easier. But yeah, that's something to consider. Uh, okay, when we were talking about refactoring, so you mentioned two categories, right? Like one category is refactoring the code, and another category is refactoring ideas. Um, we have uh, uh, Dr. Connell Elliott, who is the father of one of the two fathers of functional reactive programming, which is on which React, aforementioned as well, is based. But also, he's really big on denotational design and using kind of like denotational semantics to figure out that you're building the right it before you're building it right. And a lot of like denotational design ideas, I feel, come hand in hand with strong expressive type systems. Do you use, like, does OCaml or ReasonML now, do these technologies help you formulate your ideas better, or do you kind of like do whiteboard brainstorming and then kind of shove your idea into type system? Like, how does it go?
It's definitely a lot of both. But I have to say, my thinking has been so shaped by OCaml, it's kind of ridiculous. I think the major thing that OCaml has done for me really makes me think about data first, right? it's not which is it's very different to a lot of other languages where a lot of times you're maybe thinking about a model, or you might be thinking about an object and things you can do to that object. But the thing that I love about OCaml, and this has definitely started making its way into Grain, is thinking about the data first. And so that means you're thinking about the types first. Like the very first thing you're thinking about is, okay, how am I going to model this data? And then that's like the very first step. And then we start thinking about transforms of that data and moving that data around and doing things to it. And so I think that's a lot of how the Grain experience works out as well. Is like, okay, like there's this particular goal that we want to achieve. It's not, hey, let's just start writing code and hopefully we make it there. It's no, like, okay, this is what we're going to achieve. And it sort of, builds itself out from there. I remember way back, in school, we had this thing called the design recipe, which uh, essentially was thinking about your data, thinking about your transforms, and even thinking about like your tests up front, of just, this is how you're going to design a program. And that's a lot of, what we do today is really thinking about that in case first of like, what is the real problem that we're trying to solve, modeling it from there. And then the very end step is, okay, now we'll implement it. So yeah, I definitely I've been influenced a lot, by this sort of idea.
Right, that's really cool, and it's great that this sort of approaches also make their way into front end as well with TypeScript these days.
Absolutely.
And
Hmm.
yeah, I think, I mean, I'm not sure. I mean, in my information bubble, TypeScript already won, and there is no one writing plain JavaScript. I hope that in their
There's not a
stream,
ton of people. No, there's not a ton of people writing JavaScript these days.
that's great. Yeah. Um, yeah, that's really cool. And of course, like for the type 1 of refactorings, like I think type systems have obvious benefits. Like to name one
Hmm.
is you change a thing in one place and then the compiler tells you, what you
Oh yeah,
missed.
that's the entire development process. In the Grain compiler, if I want to implement a feature, and it's really funny, especially when I explain the Grain compiler code base to folks. I'm always telling them like it's actually really simple. We're literally just moving from IR to IR, and so essentially you just go to the compilation step, like at the very end, and you make a code change and say, okay, I want this data to output this WebAssembly code, and then the compiler graciously guides you all the way back through every phase of the compiler, making sure you're implementing like, okay, how do we parse this? How do we lex this? How do we parse this? Like, how do we, go to abstract normal form? Like, how do we, do all these different things, right? And it's really cool. And that is the development experience I want everyone to have, is make one small change and then don't try and guess. Like, let's not have engineers walking around being like, oh, should I change this thing in that file? Like, no, let's have a tool that can tell me how to do it. And that's huge. And it's funny because we have some of these features in Grain that people think are revolutionary, like with pattern matching. Like, you forget a case and the compiler tells you like, hey, you missed an edge case, and by the way, here's an example of the code that you missed. And some people who've never seen this before, it blows their mind. It's like, whoa, like that's insane. And like, this is really how you're avoiding bugs. And we're like, yeah, it's crazy. This has existed for forever. And it's just not in any of the mainstream languages, but like, yeah, it's here, and you can avoid all sorts of classes of bugs. That's one of my favorite things about languages like OCaml, is the fact that you write some code, and if it compiles, it's correct. It may not do what you wanted it to do, but it's definitely correct and is what you wrote. And that's amazing to me. And I think that's kind of lovely, right? As you're following all these compiler errors, usually by the time you actually get the program to actually compile, it usually works on the first try, quote unquote. Like, it's not really your first try because you ran the compiler command like 12 times to get to this point. But by the time you get to that point, you're usually done. And you can breathe a sigh of relief and say, I implement this feature, and you submit your PR and it's format. And because you had to use these beautiful types and think about things, the PR comments are so lovely, right? It's more just ideas of like, oh, we could express this type this way, or we can, think about this other way. It's none of the like low level like, oh, like how I hated those discussions like in JavaScript, just like, oh, well, actually, with this function they got this edge case where when it's null instead of zero, like, I hate those sorts of things. And so removing that entire class of discussions is just fantastic.
Yeah, uh, plus empty string conversions.
Yeah, exactly.
That's actually, you said that it's mind blowing to people you show it to, and I bet a lot of angry Haskellers will be like, "Oh, it's not mind blowing," but actually, for even for me, it was mind blowing the way you described, for example, adding new opcode, because I didn't think about it, right? Like, you kind of just, new opcode is new, like, constructor in your expert,
Hmm.
whatever, and then
Hmm.
yeah, that's really cool. Actually, it was very impressive for me as well. How then compiler kind of guides you to all the incomplete matches over expert, and
Hmm.
then you kind of go from there. Yeah, that's really impressive. Well, speaking of which, do you have any problem like convincing people that it's good? Because I remember when I was like kind of in my 20s, uh, I had a tough time. And again, this is the, maybe perhaps it's a function of age, right? Because as we kind of, you know, age, we have to maintain code bases, and then the time basically tells whose code bases are more maintainable.
Hmm.
Uh, but when you're just like, you know, kind of trying to convince a young engineer that, oh well, Python is cool, right? And you can write like scripts, or you can write some like uh, machine learning. Which, by the way, I'm scared to think how much poor statistics we have in the world because of R and Python. Like, it just, I'm just absolutely, it scares me truly. But anyway, so like a lot of libraries, blah blah blah, Python. Well, the argument I hear particularly a lot is, oh, it's like untyped languages or unit-typed languages are like languages for rapid prototyping, and you can't move as fast with those as with ML like languages, or any other, like, or Rust or something like that. So, like, do you have this sort of pushback? And if yes, then how do you kind of respond to it?
Yeah, so I think a lot, and I preach this, to the team all the time. The biggest thing with Grain is really how we tell our story, right? And it's all about how we talk about the language, which is why you don't see me going around talking about like, oh, here's how you do this really complex functional thing in Grain. You never hear me say those sorts of things. It's all about, here's how I can develop faster. Here's how I can build better programs. And I think when you come with that mindset, a lot of people are a lot more open to it. Because when you tell folks like, hey, you have to write your programs, a certain way, they're immediately going to get really defensive and say like, oh, but I don't want to do it like that, right? Versus like for example, on the types issue, like I think this is an amazing one, because Grain, all types are inferred, right? So I can tell someone like, hey, actually, especially people like JavaScript developers are TypeScript developers. They're like, oh, I really love TypeScript, but I got to write all these types, and it's like, oh, well, actually, imagine that the compiler just knew exactly what you were thinking when you wrote the code. Like when you wrote that plus sign on that variable, the compiler knew like, oh, well, that thing is a number, which means this argument is a number, which means in all these functions where you use this thing is a number, and I'm going to make sure you're being consistent about it. And then someone might hit you with, oh, but like the types aren't in the code, I can't see the types, so how do I know what types these things are? But these days, having amazing editor support is huge. And so with that, like, not only do we have like in VS Code, you got your code lenses where every single statement is telling you, hey, this is the type of this thing, just so you know, or you can hover over literally any value and it's going to tell you what it is. You alleviate a lot of these concerns. And you tell people, hey, you can write this exact same code. You don't even have to think about the types. You can just write the code like you might in Python. You just write the code. You just write it. You don't think about it. You run it and you're done. The difference is the compiler will let you know, in our case, hey, you did something a little bit wrong, and just make sure you clarify this or you fix this thing, so that way it's obvious, like not only to other people reading the code, but also like to you and to the compiler, right? And then it's actually pretty easy to get people on board with this. Like when you tell them, hey, it's just super magical and it's going to make sure you never make a mistake, they're really excited by that. When you tell them, hey, you can eliminate null pointer exceptions from your code like entirely, like something you never need to worry about, they get excited by that. So I think it's all about how we talk about these things and how we get people thinking about them, because then yeah, you're going to get less pushback. And I think a lot of people, as they've come to Grain, they've sort of seen like, oh yeah, like this is fine, like I can write this code, I feel really comfortable, I can use this library, it's not a huge deal. And then of course, the language, slowly sneakily starts, adding more functional concepts on you, but that's okay. Like you're with open arms, you're accepting like just how good it feels to write your programs and how confident you feel about your programs and that they're doing the right thing.
Oh yeah, I can absolutely imagine a scenario when an overwhelmed engineer who really doesn't like to type out the types isn't
Yep.
really sure about what something should be, or rather is sure of a type of something, and that's when they for the first time write that this should have this type, and then let
Mm-hmm.
compiler do their thinking for them, which is a
Mm-hmm.
like I'm not the smartest person in the world by far, and this is what I do all the time. Like I'm just, like this is why in Haskell there's this extension that allows you to do like inline type signatures everywhere, like in where blocks as well. And like I always have it enabled because like I sometimes know just like a type of one term, like in where block or whatever, and I just want someone else to think for me.
Exactly. And that's a lot of how I talk about type annotations. Is it's not like, oh, just add a type annotation for because you should. Like, no, it's we add a type annotation when we want the compiler to help us. Type annotations are a debugging tool more than anything else, right? There's maybe a couple of cases where it might make your code a bit more clear, but more than anything else, it's that exact situation of, hey, no, 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 this thing should be this, and I screwed it up somewhere. Just tell me where, right? Like that's exactly what it is. And when we talk about it, that way of like, hey, it's not getting in your way, right? It's there when you need it. Folks, they love that. Because yeah, um in TypeScript, and sorry, I shouldn't have laughed as hard as what I'm about to say. In TypeScript, one of the things like we have to annotate everything, but then TypeScript still allows us to just be like, oh, this is anything. And like that's an escape hatch that we shouldn't have, in the language. We shouldn't be able to just say, oh, this is literally anything, deal with it, right? um and that's the number one thing that bites people in the butt when it comes to TypeScript, right?
Absolutely.
And so just not having to think about that at all, and and it's like muscle memory, right? Like when you write a type annotation, you're not thinking like, oh, I'm doing it because I have to. You're like, I'm writing a type annotation because I need it right now for the compiler to help me, right? And I think it's just like really building good habits and like how we think about typing and things like that.
Yeah, and with what we discussed previously about the like using types to capture ideas,
Mm-hmm.
sometimes you aren't even sure about what you're writing, right? If you, as you
Yep.
said, if you go from kind of the shapes of data
Mm-hmm.
to the transformations, you
Mm-hmm.
sometimes know that there should like it's kind of like uh, propositions as types, and implementations of functions as proofs. Like you
Mm-hmm.
kind of know that there should exist some transformation, so you type it out,
Right.
and then you kind of prove to yourself and the compiler that such transformation exists, and here's its implementation. But by the way, I absolutely agree about your take regarding any, but gladly they have unknown now in TypeScript. And if they just deprecate any and just keep unknown, because I think they have very powerful like custom guards. You can like reason about
Mm-hmm.
that, like you can write like your own guard. And I think they also, I'm like, okay, 90% sure that they also have a way to have like unsafe coercions. So unknown plus unsafe coercion plus custom guard cover all the bases that any would cover. So yeah, I hope that they someday just deprecate any. Uh,
Yeah, I certainly hope that they do. And I think you can get, really far, with all these things. I mean, I'm still going to complain. I'm still going to complain. Like anytime I have to write type of or instance of, I'm going to complain. But that's okay. Right. Because it's at least, the compiler is telling you like, hey, in this situation, you don't know what this thing is. And like, we need to figure out what this thing is. And, that's okay. Like, I'm at least happy, with that, ideally we always know what everything is and everything's strongly typed, and we can have full pattern matching, and everything's happy. But I'll deal with it where I can.
oh, by the way, one huge. I remember as a very young person when I picked up Haskell and I tried to implement an interactive fiction game. I wanted to have the rooms in my interactive fiction world be a heterogeneous list. and it was like, I don't know,
Mm.
2010 or something like that. So, and I noticed, and back then I noticed that heterogeneous data structures, um, that also um, kind of in a way scale well. Like in a way, they you can just write another like data type and be able to shove it into this heterogeneous data structure in the future. Are Well, I mean, right now I can't say that they're really hard. Right now I would say that they're just difficult in Haskell. But back then I just couldn't figure it out. So how do you handle it in Grain?
Yeah, I think that's sort of like an interesting one. And I think probably because of where my mind goes right now. But it's like, yeah, you will create like a new enum in Grain. Like you'll say, hey, these are the things that I want to have in my list, and then it's a list of this enum, and pattern matching takes care of the rest. And that's always how I think of these sorts of things. Where yeah, it's a little bit of a tough one because like to me, like it's something that feels kind of obvious now, of like anytime I need to do something like this, of like different kinds of data like together, like it's just a wrapper. And which I will call it a wrapper to not scare people, but it's always just like, oh, I'm just going to wrap this data, and then I'm going to do lots of things, I'm going to do lots of transforms with it, and then at the end I'll unwrap it, and then we'll be pretty happy. And I think that's a lot of how we're thinking about that now. And I think the big question is, how do we make that obvious to people? How do we make it so folks can just feel like, oh, actually, yeah, this is the clear way I should write this? Because yeah, in other languages, I get terribly confused sometimes because I am usually thinking about the data first. And like anytime I need to enumerate values, I always end up asking myself, oh, well, actually, I need to stop. These are the only ones that I want.
Right, right,
Like,
right.
please don't.
This is
And
actually a very like mature approach because like my original problem was that I was kind of over engineering and I was seeing myself evolving the code base in the future, absolutely neglecting the fact that like adding a feature by refactoring is painless in Haskell and
mhm,
is painless in Grain. So this
mhm,
approach is very like kind of down to earth, and yeah, and this should be encouraged. And unless you really need like a mathematical object, like we have like recursive data types with like each new level depending on the previous one, so you can have kind of
mhm.
like this unfolding polymorphism. I'm sorry, I don't know the correct term, so Haskell crowd can boo me again. But yeah, so unless you really need like a mathematical object like this in your model, yeah, just do an enum and a list.
Yeah, which yeah, I think that's an interesting point you brought up there. Is for folks who aren't used to thinking that way, because I think a lot of people build things to be like, oh, yeah, I'm gonna have to maintain this later, and like I'm gonna build it this certain way so it's easily refactorable. Um, and that's not something I've thought about in a long time, because all code is refactorable fairly easily, and I'm always writing the code to be the most expressive for whatever idea I'm trying to convey. Um, and that's something I'm going to write down, actually, is to think of ways to get people feeling more comfortable with the idea of refactoring, and that it's okay, like write the code for how the world exists right now, and it's not a huge deal to change it later, like at all.
To wrap up our questions from me, I would ask you kind of one final question, which is how does one actually write a Grain program and then launches it as of today?
Yeah, as of today, you can head on over to our website. In our documentation, there's a page called Getting Grain. It'll direct you to either downloading binaries or how to build the compiler from source if you're if you're feeling lucky. Uh, and then you get Grain, and you can just create your first hello.gr file. Writing that program is super easy. Just print open paren the string hello, and then close paren, and that's your entire program. And then using the grain CLI, you just grain hello.gr, and that's it. And you have a WebAssembly module which runs with the grain CLI. You can run it again using the grain run command. You can run it with your favorite WebAssembly runtime. So you can run it with WASM or WASM time, like WASM Edge, whatever you feel like running it with. And that's it. We're trying to make it dead simple for people to create WebAssembly code and run WebAssembly code. And then, of course, there's next steps of like, oh, okay, now you can go run in other places. But in terms of like actually just getting to WebAssembly, it's that quick. It's super fast.
Yeah, and as you mentioned, you have language server support, which means that VS Code will work.
Absolutely. And even in fact, in our new release of today, brand new language server implemented. So just rewritten from the ground up. It's super snappy, super zippy. Your hovers are going to be crazy accurate. Like it's a good time. And with this refactor, we're going to be rolling out all of the other features to come. So like we'll have go to definition, we'll have code completion, automatic imports of libraries, things like that. So there's so much more. Like it's amazing right now, and just to think of everywhere it's going to go, I'm so excited.
That's really nice and really impressive. All right, let's go to questions. And yeah, if you want to be able to ask questions during our chats with our amazing guests, subscribe to our YouTube channel where we take questions from the audience, and of course, subscribe to Oscar's Discord of Grain Language to stay in the loop about the development of this amazing tool. And yeah, I'm going to start getting questions, I guess. We have a spicy one. So what do you think is the best entry point right now for functional programmers to start working with WASM? Should I just learn Rust?
What a spicy one. Okay, so there's a couple of different ways you can look at this, right? Rust has enough functional features, I think, for your average functional person to be pretty happy. Like you got like the strong borrow checker, it's going to be telling you, how to live your life. You've got pattern matching, all sorts of things. So you totally can, learn Rust if you are just trying to do some functional programming. I think it really depends on like the level at which you want to write the code. If you want to write super duper low level code, yeah, go ahead and pick up Rust. But if you're looking for something, a bit easier, a bit friendlier, yeah, I think it is going to be pick up Grain. I think in terms of like functional programming languages right now, those are going to be like your really good options. However, there is a Haskell to WebAssembly compiler called Asterius. And so if you specifically are a Haskell person and you want Haskell, you can check out that project as well, and you'll probably be pretty happy because it's exactly Haskell. But yeah, I'm definitely going to tell you, like, I'm not going to tell people don't write Rust. Rust is an amazing language. It's a fantastic freaking language. And even at work when I get to write it, I'm pretty excited. But at the end of the day, it is pretty low level. So sort of like Grain is like that, just higher level Rust friend. I saw someone on Twitter described Grain as being a child of JavaScript and Rust, which like I kind of agree with that. And I think that's how a lot of people can think about it too, in terms of getting into something functional, having enough of the features that you want. Some people just get a result type and they're happy. That's all they care about. But like there's different levels to it.
Right. Um, well, while we wait for more questions, if any, I'll ask one question that popped into my head. As you mentioned, the Haskell implementation for WASM. Haskell is famous for the amount of compiler extensions it has. Um, and I hope that there is some magic that Asterios, you said, that
Yes.
doesn't care about which extensions you have enabled and will just compile stuff. But what's your position and Grain's philosophy as far as you know accepting contributions from the community that perhaps change the way that Grain modules are written or some properties of the language? Do you plan to have extensions? Do you plan to to resort with to compiler flags? Like, what's the philosophy there?
Yeah, so our philosophy there is, we're trying to keep Grain like fairly well, it depends on how you define simple. But like we're trying to keep, Grain fairly simple. Like the Grain is targeted at folks who are trying to write a lot of high level code. And like I don't really expect there to be a ton. I mean, there will be people who will be like, "I want grain PPX." Like, let me, like, let me just give me a parse tree, and I got it. Like, there are going to be people like that. But I don't think that's necessarily where we really want to be with grain right now. I think a lot of how we want to see people extending the language is going to be via the macro system. Um, I think it's going to be a lot of DSLs, and I think again, it's all about how we tell the story. And with macros, it's going to be like, hey, you want this library, and it comes with its own little syntax. Like you import the library, and you got some syntax to like do some stuff with this library. And I think that's going to be the thing that helps bring a lot of JavaScript folks in. Like if I can tell you like, hey, you import this React like library, and it just comes with JSS syntax. You don't have to go configure a whole tool chain or download all this extra stuff. Like it just works. I think a lot of people will be excited. Especially I think a lot of how people feel today, especially in the JavaScript community, is what's way harder than actually writing your code is getting your environment set up and like getting all the tools together. So I think eliminating the need for all these extra tools and stuff is going to be a lot of the area that we want to focus in. I think where we're going to be spending a lot of our energy.
Oh, for sure. I even have a sad story about that. When I came back to React after several years of not being in the loop, I couldn't make it work. Like I couldn't make it like you know whatever transpile, or what's the word that
Right.
JavaScript
Yeah.
people use. Uh, and the reason was because there was an update in OpenSSL which deprecated something, and then it broke Webpack, and Webpack fixed it reasonably quickly, but no one else did. So there was
Yeah.
like a week or two, maybe even, when everything was broken, like Create React App was broken. And this is the reason why I used Alpine.js for prototyping. That was ridiculous. Yeah, it's really nice to think about that sort of like how do we give this like non-trivial capabilities to the community. Okay, I
Yeah.
think
Absolutely.
we have one last question. So Oscar said that WebAssembly is used uh, like 80% server side. It's kind of surprising. Could we get a brief elevator pitch for server side WebAssembly?
You shouldn't have asked me that. Yeah, so there's so much you can do with WebAssembly on the server. So I think that thing we were talking about, earlier about WebAssembly being that right once run anywhere language, not to completely upset the JVM, but that's sort of in a way what it's doing right now, where there's a WebAssembly runtime called Whammer, the WebAssembly micro runtime. That thing runs on literally anything. Like what if you want to run it on WebAssembly on a Nintendo DS, you totally can. Like it's like that, level, right? And so you can actually get your WebAssembly code into all these places. So with WebAssembly's sandboxing, capabilities and other things like that, all of a sudden a use case that we couldn't really have before suddenly became known. You can run arbitrary code from people you don't know safely. And that is kind of insane. That opens up a ton of opportunities. So, like what we do at Suborbital is we extend, your SaaS applications, whatever kind of application you have, with this ability for your users to write functions that do things in your app. And previously, that's something that maybe you had to run some custom Docker container solution for, which was still probably a little bit unsafe. But now we can actually completely lock down that sandbox and say, no, you are allowed to do this thing and this thing only, right? That's it. And like being able to do that is actually kind of huge. So there's a lot of use cases like this, and then even like going into like replacing Docker containers of, hey, actually we don't need these big hefty containers to do something. Like if I can have a WebAssembly module that does this one task, and I can then go and link all these modules together and do all this work, I'm all set. And that's how we end up having a lot of WebAssembly happen on the server. And even going to edge computing as well is like, hey, how do I actually push compute out to my users, right? Shipping like massive binaries or containers and deploying them all around the world is like really cumbersome. But when I have a WebAssembly module that's 100K, it's actually very easy for me to be like, okay, actually have this one module on a server in India and run it. Like that's actually like something that's much easier to consider, like it's actually very serious. And I think that's what makes us really excited about the capabilities of WebAssembly. Like, yeah, WebAssembly will be popular in the browser. Like, don't get me wrong, we are going to get there. I think the thing a lot of folks forget right now is that fundamentally JavaScript is kind of a good language. Even if it's not what people want it to be, it has done extraordinary things, and people have done extraordinary things with JavaScript. JavaScript's really fast. Some people will write their program in Rust, be like, "Oh, I'm going to write this thing in Rust and deploy in the browser," and they find out that it's not that much faster than the JavaScript version. And it's because, yeah, JavaScript engines are crazy, and like they can JIT code faster than you can believe. Like it's really, really impressive. So yeah, just outside the browser, like just running in tiny places, running, just on servers at the edge, just everything. There are loads and loads of applications that we're seeing for WebAssembly. Um, I still dream of the day that some grain code is running on a light bulb somewhere. Like I imagine that we will definitely get there.
That's really cool. That's and with edge computing example, it's basically okay, you have a server, but maybe you don't even need a server, right? At some point,
Mm-hmm.
you can, and probably you will have exactly the same code running, or exactly the same source code, like perhaps with some minor adjustments, deployed in a browser, right?
1,000%.
All right. Well, I think we're all out of questions. It was amazing to have you, Oscar. Thank you very much. And the floor is yours if you have anything to say to our viewers. Uh, Anything you want.
Yeah, absolutely. Thank you so much for having me on. This has been a load of fun. Folks, if you're interested in trying Grain, check us out at grain-lang.org. Follow us on Twitter. We're at grain_lang. If you want to hear from me and my bad takes, you can follow me on Twitter as well, at Oscar_Spen. And yeah, that's about it. Thanks so much.
All right. Thank you, and good luck with your further development.
Thank you so much.